Hi everybody. So today I will talk about some detail about the midterm exam. Unfortunately, I still don't know the time and format of the exam yet, but I found the material on Canvas, so I will go over it, including the code and underlying principles. So let's start. And in this video, I will go over the singly and doubly linked list, and I will quickly go over the insertion with head or tail. Uh, we will also talk about the insertion sort and how to using the singly or doubly linked list to achieve it. Uh, in next video, maybe tomorrow, I will post. I will also talk about how to using the the circle list. I think here, yes. I will talk about circular linked list, and also talk about the insertion, the selection sort. So let's start. Oh, by the way, we will also talk about the stack and the queue as well. So let's continue. So first, let's quickly review the single linked list in previous lecture. We talk about the single linked list. So if we want to insert a node into the sequence, first we need to create a new one, right? And then if we want using the head insertion, we just set the new node's next point to the head, like this. This one point to the head, and set the new one become to the new head. So in this way, we can insert the node into linked list, right? If we want to insert into the tail, we also need to create a new one. And then we need to traversal from the first element to the end element. You know, you cannot just directly access the last one. You need to traversal and make sure whether it's the last one, right? So we traversal from this one to this one to this one until we find the node which is the next will equal to non-pointer. This one should be the last node, right? So we set the last one's next is pointed to the new node, like this. In this way, we can achieve the tail insertion. So let's see how to using the code to achieve that. So first, we define a structure. The node is equal to data, and the next. The type of next is node pointer, right? So first, we need to run this line. We initiate a new node. Maybe the value is 3, and the three nodes next should be non-pointer. That is how we initiate a new node. So continue. If the head is equal to non-pointer, that means if the sequence, this one, the sequence is empty. Because if the head is a non-pointer, that means there's no one element in the sequence. So we just set the head equal to the new node. That means the new node will become a whole sequence in here, right? And if not, if the sequence is not empty, we need to set the new node's next will equal to head, like that. This one's next, we will point to the head. And then we set the head will become the new node. This line, right? So in this way, we can achieve head insertion. So continue. For tail insertion, oh, sorry, here's a mistake. Never mind. First, we need to create a new one as well. We set the value equal to 6. And also, if the sequence is empty, we need to set the header equal to new node, right? If not, we need to traversal all the elements. So we need to create a template for record. First, the template will equal to head. We traversal from head to the last. So the template will equal with the head because the tab of head is the pointer node. That means it will copy the head's address. So it should be a deep copy. If you change the template, and the head will also be changed. Okay, so let's traversal. Template will equal to and a template if that template next is not on non-pointer, and the template should become to templates next. So the template should become the templates next should be 8, right? This one, and continue traversal until the last one. The last one here, the template data is 7, and his next should be non-pointer, right? So here we'll break the condition. So that's why the code will jump outside of the while loop. So finally the template next will become the new node. This one new node. So it should become like that. Because the template is a deep copy of the last node. So if we set the template next is a new node, also is equal. This one next will become the new node, right? So this is the final outcome. All right, let's go. So in the next, we will talk about the double linked list. So the double linked list have some difference with the single linked list. It have a previous pointer to point to the previous node. So why we need to using the double linked list? Imagine if we traversal from the head one to the tail one, from this one to this one, when we traversal in this step, we traversal the number 2. So if we want to also access the previous node, for example, we access the 14, but we also want to access the previous node. If we're using the single linked list, we have not able to access the previous one, right? Because we haven't maybe a template to record the previous node. But if you're using the double linked list, you can just access the previous one, like you access the next one, right? Because it have also have a previous pointer to point to the previous one. That's why we needed to using a double linked list. So in the next, I will let you know how using the double linked list to implement the head and the tail insertion. So for head, first we needed to create a new node as well, and it have a previous pointer and next pointer, right? So let's continue to here, and we will need to set, because we are the head insertion, so we set the new node's next will equal to head, like this. This one's next will point to the head, and if the head is not equal to a non-pointer, that means if the linked list is not empty, we will set head's previous will become the new node. Here will change from the non-pointer to the new node, like that. So we set finally we set the head will become the new node. In this way, we can achieve a head insertion based on the double linked list. So continue. Let's talk about how using double linked list to implement the tail insertion. So we also need to create a new one as well in this line. And if the head is equal to a non-pointer, that means it is empty. So we just set this one will become the whole sequence. So we also need to create a new template for record, right? Here it should be, sorry, it have a mistake. It should be term. And then we traversal template will equal to template next. Traversal and also traversal one by one until here. And the template will become to the last one. And if here, templates next will equal to here, equal to non-pointer, right? So it will break the condition here. That's why we will jump into this line, jump to this line. And templates next will become to the new node, this one. And the new node, the preview, will become to template also, right? So like that's the whole process. Before we starting to talk about the insertion sort, I want to talk about some important thing. So I'd like to talk about the recitation. So as you know, many times there isn't much new content to cover during the recitation, right? So most of the time, I just using the period for Q&A or go over homework. And I also understand that it's not convenient for some of you to come to campus. I know some students will have will spend a lot of time on commute. So I want to make this clear. If you have attended at least 3 times recitation, you will receive 4 attendance credit. Okay, and for the future, for future recitation, I will post an announcement on Canvas in advance to let you know what I will be covering in class today. So if you are interested in the topic, maybe I will let you know. I will talk about some homework or the project, maybe exam. And if you are interested, you are welcome to join. Okay, so for recitation, that's only include the Q&A session, and we will not have an attendance check. So if I post on Canvas to let you know today's recitation class only have a Q&A session, and we will definitely not have an attendance check. Okay, so attendance will only be taken when I explicitly mention in the announcement that we will be content covered in the session. Maybe I will tell you today's we will go over some material. So we will also have a attendance check. So I hope this help save you time, right? Especially for those who have long commute. Okay, let's back to class. So let's talk about the insertion sort. The insertion sort is very simply. For example, here we have a sequence. How to sort the sequence to make it ordered. The principle is that we just split the sequence into 2 subsequences, and the green one we think this is ordered sequence. For blue part, we think this part is unsorted. So what we need to do is just traversal all the elements from the first elements of unsorted to the end, and compare the elements between the sorted one, sorted sequence with the elements, and insert the element into the correct position. So I just take to the professor on the phone. The professor will post a video next week about the project 2 and the midterm 1 schedules. And our programming challenge will be taking place during the class. So let's back to the lecture. So we need to insert the element into the correct position, right? So after that, the ordered sequence will become contain 2 elements. And here is also the unsorted sequence. And then we need to choose this one and compare with the ordered sequence, compare with the 8 and the 12. So it should be between the 8 and the 12, right? So we need to insert into this part like that. And finally, we will insert all the elements into the correct position inside of all the sequence. So finally, we will get the whole sequence, right? Like that. All right. So let's talk about how using the code to implement the function. So first, we needed to check if the head is non-pointer or head next is equal to non-pointer. That means the head is empty or the head only have one element. In this case, the sequence must be ordered, right? For example, if you are running a race, but there's only you are running, it must be the champion, right? So if not, if the sequence at least have two elements, we will jump to this line. Oh, by the way, all the code I will also attach on the announcement laterly. Okay. So first they create a sorted node, which is equal to non-pointer. And then we create a current equal to head is also a deep copy. And if the current is not non-pointer, because we will traverse all the sequence. So if the current is not non-pointer, we will continue the while loop, right? We will also create a next, which is equal to current next. The current next should be the 8, right? And then if sorted is equal to non-pointer, or sorted data are greater or equal than current state, the sorted is equal to non-pointer, so it will trigger the position, trigger the condition here. The current next will become sorted. This one is next. It should be this one, right? It will become the sorted. And then we set the sorted become to current, right? And this one will become the new ordered sequence. And then we set current will become the next, this one, right? And finally, we need to back to the while loop. And currently, the current is not a non-pointer, right? So we will jump to this line. And if the and also we need to refresh the next. The next will become current's next. Current's next should be this one, right? The 11. This one. So we continue go to the if sort is equal to pointer or sorted data, the 12 is greater and equal than the current data. Actually, you can imagine. So we regard this one, the 12, as a sorted sequence, and then we traverse all the elements from the first one from the 8 to the tail, right? We traverse all the elements and compare with the sorted sequence and insert into correct position. So that's why we compare sorted data and the current data. So the 8 is less than the 12, right? So we will jump to this line. the current data, the next will become sorted. This one's next will become this one. That makes sense, right? Because there is the correct position, so we just insert using the head insertion to insert the 8 into here, right? And we set the sorted will become the current. This one, sorted will become this one. It was like the sorted will. It was like a head, the head over the sorted sequence, right? So we continue, jump to this line. The current will become the next. So the current will become the next element, which waiting for sorting, right? So